Welcome to Loading Models. This lesson is part of Module 04, First Fine-Tuning Project. Let's get started. Let's now look at Lesson 4.1, Loading Models with Unsloth. Here we can see the model loading pipeline. Let's now look at Overview. Here we can see the quantization memory savings. Before training, you need to load a pre-trained model. Unsloth makes this incredibly easy and memory efficient. In this lesson, you'll learn to load models properly, understand quantization, configure low-rank adaptation adapters, and verify everything is ready for training. Duration, 30 minutes. Difficulty, intermediate. Let's now look at learning objectives. Here we can see the LoRa config anatomy. By the end of this lesson, you will load pre-trained models with Unsloth, understand 4-bit quantization, configure low-rank adaptation adapters, rank, alpha, target modules, check model memory usage, verify model is ready for training, understand model architectures. Let's now look at choosing your model. Here we can see the trainable params comparison. Let's now look at, for this module, Llama 3.2 3B Instruct. Here we can see the model loading options. Why this model? Small and fast, got 6 GB of RAM in 4-bit, high quality outputs, perfect for learning, trains quickly on Tesla P40, recently released 2024, model card, Meta Llama 3.2 3B Instruct. Let's now look at other options. Here we can see the quantization comparison. Model, size, RAM at 4-bit, training speed, quality. Size, Llama 3.2 1B Instruct, 1B 3 GB, very fast, good. Llama 3.2 3B Instruct, 3B 6 GB, fast, better. Llama 3.1 8B Instruct, 8B 12 GB, medium, best. Mistral 7B Instruct V03, 7B 10 GB, medium, excellent. Quen 2 5 to 7B Instruct, 7B 10 GB, medium, excellent. For Tesla P40, 24 GB. All of these fit comfortably. Let's now look at loading your first model. Here we can see the LoRa target modules. Let's now look at Step 1, Import Unsloth. Here we can see the memory footprint profile. In Jupyter Notebook. Here's the bash code for this section, starting with PyTorch version 2.5.1cu121. Let's now look at Step 2, Configure Model Loading. Here we can see the loading pipeline detailed. Model configuration. Parameters explained. Model name. Unsloth has optimized versions of popular models. Max JOTS secu length. Longer, more context, but more memory. D-type. None, JOS auto. Float 16 on Tesla P40. Load. In 4-bit. Reduces memory by 4x. Let's now look at Step 3, Load the model. Here we can see the model config anatomy. Here's the Python code for this section, starting with, from Unsloth import fast language model. First time, downloads, Toktra 2G buyers, model waits. Subsequent times, loads from cache, starts at 10 seconds. Expected output. Here's the bash code for this section, starting with, model loaded successfully. Let's now look at Step 4, check memory usage. Here's the Python code for this section, starting with import torch. Expected output, Llama 3.3B and 4-bit. Here's the bash code for this section, starting with GPU 0, Tesla P40. Perfect, plenty of memory left for training. Let's now look at understanding 4-bit quantization. Let's now look at what is quantization. Quantization, reducing precision of model weights to save memory. Normal precision, float 16. Each parameter, 2 bytes, 3B parameters, 6G by 4-bit quantization, bits and bytes. Each parameter, 0.5 bytes, 3B parameters, 1.5 GB, plus overhead, shutting 6 GB total. Let's now look at quality impact. For low-rank adaptation fine-tuning, minimal quality loss, 1%. Training works perfectly. Inference is fast. 4x memory savings. Use float 16 only if you have 80 GB plus VRAM. Training very large models need absolute maximum quality. For Tesla, P40, Always use 4-bit. Let's now look at configuring LoRa adapters. Let's now look at what is LoRa? Low rank adaptation. Low rank adaptation. Train only small adapter layers instead of full model benefits. Train only 1-2% of parameters, much less memory. Faster training, tiny adapter files, shown 50-100 mallops versus 6G by full model. Let's now look at LoRa configuration. Add LoRa adapters to model. Let's now look at rank. 8, very small, fast, less flexible, simple tasks. 16, good balance, recommended for most tasks. 32, more capacity, complex tasks. 64, maximum capacity, rarely needed. For this module, use ROICHUS 16. Let's now look at target modules. Which transformer layers get low rank adaptation adapters standard set, recommended? Here's the Python code for this section, starting with QProj, KProj, VProj, OSProj, GateProj, UpPro. Here's the Python code for this section, starting with QProj, VProj. Let's now look at LoRa alpha. Scaling factor for low rank adaptation updates. Rule of thumb, set equal to R. R yosh to 16. LoRa arsh alpha tot to 16. Let's now look at LoRa dropout. Regularization, prevents overfitting. 0. No dropout, faster, recommended for small datasets. 0.05, light dropout. 0.1, medium dropout, if overfitting. For this module, use 0. Let's now look at use gradient checkpointing. Trade computation for memory, unsloth. Unsloth's optimized version, best. True, standard PyTorch version. False, no checkpointing, more memory. For this module, use unsloth. Let's now look at inspecting the model. Let's now look at check trainable parameters. Here's the Python code for this section, starting with defprint trainable parameters on model. Expected output, Llama 3.23b with low rank adaptation ITOR 16. Here's the bash code for this section, starting with trainable params 41943z040. All params 32113 way to rate is only training 1.3% of parameters. That's the magic of low rank adaptation. Let's now look at view model architecture. See model structure. Here's the bash code for this section, starting with fast Llama model. Note, linear 4-bit gives 4-bit quantized layers. Let's now look at test tokenizer. Test tokenization checks special tokens. Here's the bash code for this section, starting with text, hello, how are you today? Let's now look at test inference before training. Let's now look at generate with base model. Apply chat template, test prompt format with template. Let's now look at generate response. Prepare for generation, tokenize, generate, decode. Here's the bash code for this section, starting with the person's name is John Smith, age is 35, and occupation I. After fine-tuning, it will output clean JSON. Here's the JSON code for this section, starting with C. Let's now look at complete loading script. Say this is notebooks 03 first training 01 load model.ipynb. Cell 1, imports. Cell 2, check GPU. Cell 3, load model. Cell 4, check memory. Cell 5, add LoRa adapters. Cell 6, check trainable parameters. Let's now look at verification checklist. Before moving to the next lesson, confirm. Here's the bash code for this section, starting with model loading checklist. Let's now look at hands-on exercise. Let's now look at exercise, load a different model. Try loading Llama 3.1 8b instruct and compare. Your task, 1. Load Llama 3.1 8b instruct. Unsloth Llama 3.1 8b instruct. 2. Check memory usage. 3. Add LoRa adapters. 4. Count trainable parameters. 5. Compare with 3B model. Let's now look at key takeaways. 1. Use unsloth. 2x faster than standard transformers. 2. 4-bit quantization, essential for Tesla. P40. 3. Low rank adaptation adapters train only 1-2% of parameters. Standard rank, R to 16 works for most tasks. 5. Verify first, test inference before training. 6. Check memory, ensure enough space for training. Let's now look at what's next. Model loaded. Now you need to prepare your training data properly. Continue to. Lesson 4.2, preparing your training data. Let's now look at additional resources. Unsloth documentation, low-rank adaptation paper, quantized low-rank adaptation paper, PEFT library. Lesson complete. Mark is done. That wraps up loading models. Well done on completing this lesson. See you in the next one.